DC generator is typically found in off-grid applications. These generators give a seamless power supply directly into electric storage devices and DC power grids without novel equipment. The stored power is carried to loads through DC-AC converters. The DC generators could be controlled back to an unmoving speed as batteries tend to be stimulating to recover considerably more fuel. Working principle of DC generator. In the first half of rotation, current always flows along ABLMCD, that is, brush number 1 in contact with segment A. In the next half revolution, the direction of the induced current in the coil is reversed. But at the same time the position of the segments A and B are also reversed, which results that brush number 1 comes in touch with the segment B. Hence, the current in the load resistance again flows from L to M. The waveform of the current through the load circuit is shown in the figure. This current is unidirectional. This is how a generator works. Parts of DC generator. Magnetic frame or yoke. The outer hollow cylindrical frame to which main poles and interpoles are fixed and by means of which the machine is fixed to the foundation is known as yoke. It is made of cast steel or rolled steel for the large machines, and for the smaller size machine the yoke is generally made of cast iron. Pole core and pole shoes. The pole core and pole shoes are fixed to the magnetic frame or yoke by bolts. Since the poles project inwards, they are called salient poles. Each pole core has a curved surface. Usually, the pole core and shoes are made of thin cast steel or wrought iron laminations which are riveted together under hydraulic pressure. The poles are laminated to reduce the eddy current loss. Commutator. The commutator, which rotates with the armature, is cylindrical in shape and is made from a number of wedge-shaped hard-drawn copper bars or segments insulated from each other and from the shaft. The segments form a ring around the shaft of the armature. Each commutator segment is connected to the ends of the armature coils. Commutator is the most important part of a DC machine and serves the following purposes. It connects the rotating armature conductors to the stationary external circuit through brushes. It converts the induced alternating current in the armature conductor into unidirectional current in the external load circuit in DC generator action, whereas it converts the alternating torque into unidirectional, continuous, torque produced in the armature in motor action. Armature. The armature core of DC generator is cylindrical in shape and keyed to the rotating shaft. The armature core of a DC generator or machine serves the following purposes. It houses the conductors in the slots. It provides an easy path for the magnetic flux. Brushes. Carbon brushes are placed or mounted on the commutator, and with the help of 2 or more carbon brushes, current is collected from the armature winding. Each brush is supported in a metal box called a brush box or brush holder. The brushes are pressed upon the commutator and form the connecting link between the armature winding and the external circuit. Shaft. The shaft is made of mild steel with a maximum breaking strength. The rotating parts like armature core, commutator, cooling fans, etc. are keyed to the shaft. The shaft is used to transfer mechanical power from or to the machine. Classification of DC generators. DC generators are classified according to the way their magnetic field is developed in the stator of the machine. Permanent magnet DC generators. Separately excited DC generators. Self-excited DC generators. Permanent magnet DC generators. Permanent magnet DC generators do not require external field excitation because it has permanent magnets to produce the flux. These are used for low power applications like dynamos. Separately excited DC generators. Separately excite DC generators requires external field excitation to produce the magnetic flux. We can also vary the excitation to get variable output power. These are used in electroplating and electro-refining applications. Self-excited DC generators. In this type, field coils are energized from the current produced by the generator itself. Initial EMF generation is due to residual magnetism in field poles. The generated EMF causes a part of current to flow in the field coils, thus strengthening the field flux and thereby increasing EMF generation. Self-excited DC generators can further be divided into 3 types. Series wound, shunt wound, compound wound. Series wound. In this type, field winding is in series with armature winding. Shunt wound. In this type, field winding is in parallel with armature winding. Compound wound. It is the combination of series and shunt winding. Advantages of DC generator. Mainly DC machines have the wide variety of operating characteristics which can be obtained by selection of the method of excitation of the field windings. The output voltage can be smoothed by regularly arranging the coils around the armature. This leads to less fluctuations, which is desirable for some steady-state applications. No shielding need for radiation, so cable cost will be less as compared to AC.